multiplication of vectors. A vector is multiplied in three ways. Number first is product of a vector, of a vector by a scalar quantity. Second is scalar product of two vectors. And third is vector product of two vectors. Now these two are most important for this one. First is very simple. First is product of a vector by a scalar quantity. A vector by a scalar quantity is multiplied directly. For example, vector A is given 2i minus 3j plus 2k. We have to find 2a. It means we have to multiply vector A by 2. Or 2a is 2 into 2i minus 3j plus 2k. That's 2a will be 4i minus 3j and plus 4k. Now one example, mass of an object is 2 kilogram. The force F is due to this force an acceleration of A is 2i plus 3j plus k Newton, k meter per second square, produces in it. Find the magnitude of force. Find the magnitude of force. Now the solution. Given mass of object m is 2 kilogram, acceleration vector A is given 2i plus 3j plus k meter per second square. We have to find that's F. It is to be found, and also magnitude F vector is to be found, because F is equal to ma. On putting the values of a and m, we get F will be 2 into 2i plus 3j plus k. So value of F will be 4i cap plus 6j cap plus 2k cap Newton. To find the magnitude F, of vector F is square root of fx square plus fy square plus fz square. So F will be 4 square plus 6 square plus 2 square, that's 16 plus 36 plus 4, or F is square root of Newton. The required answer. Now question 2. Mass of an object is 5 kilogram. It is moving with velocity v is 2I minus j minus 3k meter per second. Find the momentum of that object. Find the momentum of the object. Now the solution. Momentum P is given by m into v. Here is v vector, so P will also be vector. So P will be as 5 into 2I minus j minus 3k. The value of P will be, vector P will be 10I minus 5j minus 15k. That's kilogram into meter upon second. We want to find the magnitude of this one, magnitude of vector momentum, magnitude of vector P is P, that will be square root of 10 square plus square root of minus 5 square plus square root of minus 15 square, that will be 100 plus 25 plus 2 to 5. Our P will be square root of 350 kilogram into meter upon second. Now the second, scalar product of two vectors. If we multiply two vectors in such a way that the product is a scalar quantity, this product is known as scalar product or dot product of two vectors. If we multiply two vectors in such a way that product is a scalar quantity, then the product is known as scalar product or dot product of two vectors. For example, if we multiply force and displacement, it gives work. Work is scalar, but the force and displacement both are vector. Product of force F and displacement B gives work done, which is a scalar quantity. So we can write work W, that will be F dot B. Now suppose an object is placed at this point, a force acts on this object, that's F, and displacement is at an angle of theta. This one is D. We find the work done. Because of work done is force into displacement. In the direction of force. To find the work done, we will multiply force and displacement only when they are in the same direction. So we will break D in the direction of force. That's it will be D cos theta in this way. So work done W, that will be F into D cos of theta. We will write this one F dot D. It means F dot D is F D and cos theta. Here theta is the angle between D and F, displacement and force. F is the magnitude of, here is F is magnitude of vector F, and D is magnitude of vector D. Commutative law in vector product, scalar product. Commutative. By the law of commutation, by the law of commutation, A dot B is equals to B dot A. Now we want to take the example. This one is any object. A force acts on it. The object displaces by displacement D. The angle between F and D is theta. And now because of work done is force into displacement in the direction of force means work done W is F into D cos theta. This angle is, that will be D cos theta, or we can also write this F dot D, number one, or we can also write work done is displacement into force in the direction of displacement This one is displacement, here is force F, here is F cos theta, F cos theta. So we can also write W is, work done is D into F cos theta, that's D dot F, number 2, from 1 and 2 we get F dot D is D dot F, means dot product of vectors is commutative. Scalar product of two vectors is commutative. Now some special cases. Number one is scalar product of two parallel vectors. Suppose vector A is parallel to vector B. It means angle between them, angle between A and B that's theta is 0 degree. So A dot B is AB cos of 0 is only AB because cos of 0 is 1. For example, A dot A that will be A square, B dot B is B square and so on. Now the second case, scalar product of two perpendicular vectors. Suppose A is perpendicular to B, then angle between them, that's so theta will be 90 degree. Means A dot B is AB cos 90 because cos 90 is 0, so A dot B will be 0. Now the third case, scalar product of two parallel unit vectors. Generally we know unit vectors are I, J and K. So parallel unit vectors means we have to find the dot product of I and I dot I, that will be 1 magnitude of I cap into 1 into angle between I and I is 0 degree, that will be 1. Same J dot J, that will be 1 into cos of 0 degree, that's also 1, and K dot K is also 1. It means I dot I, that's J dot J, is K dot K, all are 1. Now the fourth point is scalar product of two perpendicular unit vectors. I, J, K are mutually perpendicular. Means we have to find the product of I and J, J and K, K and I dot J. That will be 1 into 1. Magnitude of I cap is 1 and J cap is also 1. So 1 into 1 into cos of 90, that will be 0. We know I dot J, that will be J dot I cap into sum, that will be 0. Same thing, J dot K, that will be 1 into cos of 90, that's 0. And K dot J is also 0. k dot I, that will be 1 into 1 into cos of 90, here is 90, that will be 0, and k dot j dot k, I dot k, that will be also 0. Hence I dot j dot k equals to k dot I equals to j dot I is equals to k dot j, that's I dot k, all are 0. These are the results of a scalar product. Now one example. A is given to I minus 3j plus 4k, and B is I plus j plus k, find it dot B. A dot B is 2I minus 3j plus 4k dot I plus j plus k. Here we will multiply only I dot I, j dot j and k dot k. The rest will be 0 because I dot j is equals to k dot j and I dot k all are 0. So we will multiply here only. A dot B is 2 into I dot I minus 3 into j dot j and plus 4 into k dot k. Here I dot I is equals to j dot j is equals to k dot k are 1 and rest are 0. Rest are 0 means I dot j is j dot k is k dot I, all are 0. So A dot B will be 2 into 1 minus 3 into 1 plus 4 into 1, that's A dot B is 2 minus 3 plus 4, that's 3, the required answer.